about thermodynamic. So what's the meaning of the word thermodynamics? The word thermo means heat. And the word dynamic means mechanical. So now, what will be the meaning of thermodynamics? What's actually thermodynamics? So in simple words, the relationship between heat energy and mechanical energy is called thermodynamics. Let me just do this for clearance. The relationship between heat energy and mechanical energy, or else you can say conversion between or in simple words, conversion of heat energy to mechanical energy or mechanical energy to heat energy is called thermodynamics. So there are some terms in thermodynamics. The first term we're going to discuss is thermodynamic system. Thermodynamics system. So what's basically thermodynamic system? Any material or quantity, let me just write it with that, any material or quantity of matter enclosed by a boundary which is influenced by heat is basically called thermodynamic system. Let me give an example of it. For example, we have a glass of water. Okay, so here, as we see the definition, any material or quantity. So for example, water is here the quantity or the material we are talking about, of matter enclosed by a boundary. You can clearly see the water is enclosed by the boundary of glass. Okay, here's the water and it's enclosed by the boundary of glass, which is influenced by heat. Now here the water can easily get influenced by heat. For example, it's a cold glass of water, okay, and I placed it on my table. Okay, I placed the glass on my table, and by the time pass, it will turn into simple normal water because of the temperature outside. Okay, influenced by heat, it was cold, but due to the temperature, due to the room temperature on my table, because it was placed on my table, it turned or it converted into normal water. Okay, now let's come on the second term, which is surrounding. Surroundings. So what is basically surrounding? It's so simple. Anything outside the system, anything outside the system to which it exchange heat, Ignore my writing. Okay. If I talk about an example of here, for example, a car engine. Okay, you have noticed the car, if you have a car engine is not on in any system, it's open to the surrounding. Okay, whenever you placed in a car in hot heat, like it's hot summer and you have placed your car outside, you have parked your car outside your house, the engine will automatically turn, like gain a lot of temperature. Okay, the engine will automatically get hot. Well, if it's winter and your car is outside, the engine will either be like cold or on normal temperature. Okay, so it can be a simple example of surroundings. Now let's come to the main point. So we have three type of systems. We're going to discuss with the first one, which is open system. Open system. So what is open system? It can exchange both matter and heat. Okay, let me write it here. It can exchange both matter and heat. Anything which can exchange both matter and heat. For example, a cup of tea. A cup of tea. Example, a cup of tea. Okay, you can. Now let's come to the second system, which is closed system. Okay, so closed system is basically, it can exchange heat but not the matter. Okay, it can exchange heat but not the matter. Let me write the definition here. It can exchange heat but not the matter. Example can be simply sealed water bottle. I think I should elaborate the first example a little more. For example, we are having a fire here and it's a stove. Okay, in the stove here is the tea. We're making tea. So when the stove is when the matter is heated, so the steams come out and react with the air vapors. Okay, and the temperature inside of the tea, the liquid, is getting hot because of the steam. So here both the steam and the heat is increasing. Okay, while in closed system, a sealed water bottle, if a water bottle is sealed, okay, and you have placed the water bottle in the refrigerator, at that point only the water will get cold. Okay, and as it's closed, the air cannot get inside the water bottle, so means it cannot exchange, it can exchange heat but not the matter. So the matter cannot be exchanged because not any type of matter is getting inside the bottle as it's sealed. Okay, now let's continue to our last system, which is isolated system. Isolated system. So what's basically isolated system? So it cannot exchange either matter or heat. Okay, it can not exchange either matter . Okay, and what can be a good example of it? I think a thermos. I don't know if you guys know about a thermos. So thermos is something in which the first of all, thermos is closed, okay, so there is nothing of matter, okay, you cannot exchange the matter over there, and even not heat can enter inside because it's made to some isolated boundaries that heat cannot easily get in, heat can actually not get inside, okay. And thermos is a temporary example for it. Temporary means it's a isolated system, don't have any permanent, like not have any accurate example, because this system not exist in actually when it comes to transfer of heat or matter. So thermos can be an example to understand it, because in thermos, if you keep the water cold, it will remain cold for the entire day, and if you keep a hot water or a tea in it, like hot tea or coffee, it will remain hot, okay. So a thermos can be an example of the isolated system, okay. Now towards, I think, the second last or the last term of today, which is thermodynamics variable. Thermodynamics, it's one of the important terms. Okay, so what are thermodynamics variables? Okay, so in simple words, if I could explain, parameter of systems such as, okay, parameters of systems such as pressure, such as temperature, volume, let me even put the terms, temperature, pressure is by P, and internal energy, is denoted by a capital U, and number of mole, which is basically by N, denoted by N. So these are the thermodynamics variable on which the process all matters. Thermodynamics basically lies on, okay, like in simple words, the parameter of thermodynamics. Okay, now we're gonna come on another term, which is thermodynamic process. Let me write it. Thermodynamic process. So it is a process in which change in thermodynamic, like changes the state of the system. For example, the change in thermodynamics changes the state of the system. Like variable can change. Okay, let me write the definition first. Like change in the process will change the state of the system, in simple words. If I could write, it's change in thermodynamics, will change the state of the system, okay. Now what is internal energy? Okay, so internal energy, let me write here, internal energy. So internal energy, it's, as in simple words, is the sum of potential energy and kinetic energy, okay. Potential energy and kinetic energy, which is basically possessed by the molecule, okay. I think it's clear. So kinetic, and I think you guys know it from before, that potential energy is change in motion. Change is due to change in motion, and kinetic energy, basically it's change in, kinetic energy is basically change in motion, while potential energy is change in configuration. Change in configuration. Am I writing? Okay. So if I have to represent it mathematically, so this will be mathematically this will be okay, as I told you before, internal energy is represented by capital U is equal to kinetic energy, which is Ke, plus potential energy, which is Pe. Okay, and you can, okay, as I told you, internal energy is basically the sum of potential energy and kinetic energy. So you can write it also like U is equals to UK, means in simple words it can be kinetic energy, and you can also write potential energy like UP. Okay, and now towards the last term of the day, which is so simple, we'll end it in a second somehow. It is indicator. Okay, let me change my writing and the pen too. Indicator diagram. You can simply guess it with its name, indicator diagram. As I told you, mathematically it's sometimes indicator diagram too. Okay, there will be a in exam in the spelling, ignore that. So indicator diagram is basically the graphical representation of something, which we're gonna study further in this chapter. Okay, hope so this is clear. Let me just give out to what all we have studied. Okay, so we have started from thermodynamics, which is basically heat and mechanical, like the relationship between and conversion between heat and mechanical energy. Okay, we have studied about thermodynamic system, we have studied about surrounding, about three systems: open system, closed system, and isolated system. With that we have learned about with that we have learned about thermodynamics variable, which are total 5, and thermodynamic process, internal energy, which is basically the sum of potential energy and kinetic energy, and mathematically can be written like that. With that, the last thing we have studied is indicator diagram, which is basically the graphical representation of something. Thank you.